Here are some examples of adding polynomials together. We'll start off with a pretty basic one. How about something like x plus 3, and we're going to take that entire quantity and add it to 2x minus 9. Anytime you're doing these sorts of problems, it's important just to realize when you're starting off what can be matched up and what can't be matched up. So we need to identify that first. We have some x terms in here, we have some non-x terms. The x term on the left is just 1x, and then over here on the right we have a 2x. Okay, it's kind of like apples and oranges. We can't mash those things together. So we have the x terms, and then we have the constant terms, so 3 and 9, and that's technically a negative 9 if you were to convert that to plus a negative 9 instead of minus 9, which we will do. If it's helpful, you might want to rewrite everything out using just your commutative and associative properties of addition. Since this is all just addition and subtraction, things can be reordered and it doesn't matter, at least for this type of problem. So x plus 2x, and now let's add those constant terms together. So we have the 3 and minus 9. You can think of it as 3 minus 9, or you can think of it as 3 plus negative 9. So right now let's do 3 plus negative 9, since we're still using that plus in the middle to do the problem. Okay, and now let's just simplify it out. So x plus 2x becomes 3x. And then 3 plus negative 9, same thing as 3 minus 9, which is going to be negative 6. So there's our final answer. Let's try a new one. This time I want to add two trinomials together, so that's something a little more complex. How about 3x squared minus 4x plus 8? And let's add that entire quantity to 2x squared minus 7x squared minus 5. So we're going to be using the same concept here. We just have a couple more terms to look at. So this time there's a square term in there. And that's okay. We'll just match everything up like we did in the last problem. Let's identify what can be matched up. We have a 3x squared and a 2x squared. Okay. Oh, I did not mean to make the 7x squared. It's just going to be 7x. So 3x squared and 2x squared. Once again, we can use the commutative and associative properties to just kind of reorder these things, since everything is just added. Okay, and if you like, you can mark out what you've used. All right, next let's identify the singular x terms, or the linear terms. So we have a negative 4x and a negative 7x. Here we are. Once again, if you'd like to rewrite those out, you can. So minus 4x minus 7x. You can also think of that as plus negative 4x and plus negative 7x, if that makes a little more sense. And then lastly, let's identify those constant terms. So we have a plus 8 and a minus 5. And you can think of that as plus 8 plus a negative 5. So we've got it all in order this time. Now let's add everything up. Add those like terms. Once again, the x squared terms and the x terms don't get added up together. It's just like apples and oranges. You can't match them up. So 5x squared for the first one, minus 4x minus 7x, or if you think of it as plus a negative 4x plus negative 7, so negative 4 plus negative 7 is just negative 11. And then 8 plus negative 5 is just going to be 3. let's rewrite that out one more time. So 5x squared minus 11x plus 3. There's our final answer. That's as simple as we can make this. We can't combine anything else.